All right, let's talk about hydrogen. For decades, it's been this almost mythical fuel of the future, right? The thing that could finally get us off fossil fuels and actually hit our climate goals. But if it's so amazing, why aren't we using it everywhere? Today, we're going to cut through the hype, look at the history, and get real about whether the hydrogen revolution is finally here. I mean, this is the dream, isn't it? Just imagine a world where our cars, our ships, even our giant factories run on a fuel, and the only thing that comes out is clean water. No carbon dioxide, no smog, nothing. That is the incredible promise of hydrogen.
And that really brings us to the billion-dollar question. We've heard this story before, There have been waves of hydrogen hype that just fizzled out. So what's been holding it back all this time? And is this time really any different?
Okay, first things first. To really get what's at stake, we need to understand the basics. So, how is this hydrogen dream supposed to work anyway?
So here's the thing. Hydrogen is literally everywhere. But on our planet, it doesn't really like to be alone. You can't just dig it up or drill for it. It's almost always attached to other things, most famously to oxygen, which gives us H2O, water. So the first big challenge is just figuring out how to split those molecules to get pure hydrogen we can use.
And this is a super important point to get your head around. Hydrogen isn't an energy source like oil or the sun. It's more like a battery. It's an energy carrier. You have to use energy, say from solar or wind, to make the hydrogen. Then that hydrogen holds on to the energy until you're ready to use it. That distinction is key to the whole debate.
And this is where the magic happens. Inside something called a fuel cell, you take the hydrogen you made and you mix it back with oxygen from the air. But instead of burning it, a chemical reaction creates electricity. And that electricity can power a car motor or a ship or whatever you need. And the only things left over are a little heat and, you guessed it, pure water. It's an incredibly clean, really elegant process.
And the potential uses are just massive. Yeah, we think about cars, but hydrogen's real sweet spot might be the stuff that's super hard to clean up with just batteries. Think about making steel and cement, or powering long-haul trucks, container ships, and even airplanes. I mean, NASA has been using hydrogen to power spacecraft since the 60s. So, if the idea is this good and has been around for so long, what went wrong? Why did it fail before? Let's take a look at the history because it's got some serious baggage.
Well, it comes down to a few big roadblocks. For one, the Hindenburg disaster created this massive public relations problem that has lasted for almost a century. Then, for decades, it was just way too expensive to make hydrogen cleanly. And even today, we have trillions and trillions of dollars already sunk into our existing oil and gas infrastructure. That system is not going to give up without a fight.
But we have to talk about the Hindenburg because it's the elephant in the room. The truth is, most experts now agree that the hydrogen didn't explode. The fire was most likely started by the flammable paint on the airship's skin. The hydrogen burned for sure, but that's very different from an explosion. That one image has created a huge misperception that just won't go away.
And this really puts things in perspective. Modern hydrogen tanks are amazing pieces of engineering. They're super tough, super safe. Meanwhile, we all just casually drive around with tanks full of gasoline, a highly flammable, pretty toxic liquid, and we don't even think twice about it. The safety fears around hydrogen are, for the most part, pretty overblown.
Okay, so maybe it's safer than we've been led to believe. What's the holdup now? Well, for that, let's do a little reality check and see how hydrogen stacks up against its main rival in the clean energy race, batteries.
So here are the trade-offs. On one hand, hydrogen packs way more energy for its weight. That means more range for a truck or a plane, plus you can refuel in about 5 minutes, just like at a gas station. On the other hand, batteries can tap into the electrical grid we already have everywhere, but they're heavy, and we've all been there, they can take a long time to charge.
And that leads us to the classic chicken and egg problem. Car makers don't want to build 1 million hydrogen cars if there's nowhere to fill them up, and nobody wants to build expensive refueling stations if there are no cars to use them. This infrastructure puzzle is probably the single biggest thing holding hydrogen vehicles back right now.
But let's say we solve that. There's another huge question we have to ask. Even if we can make it and use it, just how green is hydrogen really? You see, not all hydrogen is created equal. They actually talk about it in colors. Most of what we make today is gray hydrogen, which is made from natural gas and actually creates a lot of CO2. Then there's blue hydrogen, which is the same process, but you try to capture the carbon. But the holy grail, that's green hydrogen. That's when you use renewable energy like solar to split water, and that process is totally emission-free. But even green hydrogen has a catch. It's an issue of efficiency. Look at this chart.
When you take 100 units of perfectly good renewable electricity and use it to make hydrogen, you lose about 30% of that energy in the conversion. So you're left with only 70 units of energy. And that leads critics to ask a pretty fair question. Why not just put that original 100 units of electricity directly into a car battery?
Okay, so you've got infrastructure problems, it's expensive, and there are efficiency questions. So why are we even talking about a hydrogen revolution? Well, because this time, something fundamental has changed. Let's look at the evidence.
See, unlike all the other times, this new push is being driven by two massive forces at once. First, the technology is getting way better and way cheaper. And second, you have governments all over the world making serious, legally binding commitments to decarbonize. For the first time, there's a real global market that's willing to pay for clean solutions.
And you can see the scale of this thing. We're talking more than 350 large-scale hydrogen projects already in the pipeline around the world. That's not just an idea anymore. That's real, concrete momentum.
And of course, you have to follow the money. We are looking at a projected investment of $500 billion, $500 billion. When you see that kind of money pouring in from both governments and private companies, you know they're betting on this being the real deal.
And countries are setting some wildly ambitious goals. Take China, for example. They're aiming to have 1 million hydrogen fuel cell vehicles on their roads by 2030. When a country sets a target that big, it sends a powerful signal that builds an entire industry.
So what does this all mean? Well, hydrogen isn't some magic bullet that's going to solve everything. For cars and short-term stuff, batteries and electrification are probably going to lead the way. But for those really tough, heavy-duty jobs like shipping and steel and long-haul trucking, hydrogen is carving out a vital niche for the long haul. So, it really feels like the hydrogen revolution is finally happening. The debate isn't really about if anymore, it's about where and when. It won't power our whole world, but for the most difficult parts of our economy, it might just be the crucial piece of the puzzle. The real question we're left with now is, what are we going to power with it?